All right, we are now looking at target 9.5, so we have to moving backwards again after jumping to 9.7 in class today. But 9.5 is really just going back to what we did with solving. We looked at part of it during 9.7 when we solved, and it's just with word problems. So sometimes we'll be given the function, and sometimes we will have to create the function ourselves. Looking back what we did at like 9.1. So looking at our example 1, it says, Joe is about to buy a brand new truck. He's curious about its estimated value after the first few years of ownership. Based on some research, he created V of t equals 24,500 times 0.87 to the t, where t represents the numbers of years he has owned the truck. What is the initial price of the truck? Remember, our initial price comes from that A value. Okay? So our initial price of the truck was 24,500. What rate did Joe use for the depreciation of the truck's value? Okay. Remember, that comes from here, but this is one of two things. It's either 1 plus R or 1 minus R. Since this is 0.87, it's 1 minus R. Okay. 1 minus R. And if you do that, you get 0.13. Right. How far away is 0.87 from 1? It's 0.13 away, which goes to, right, if we move that decimal place twice, 13%. What is the value of the truck after 8 years, right? So this is something we looked at in 9.7. So again, just kind of review here. Right, so I'm going to do V of 8. Right, so V of 8 equals 24,500 times 0.87 to the 8, which equals, so 24,500. So you get 8,041 and 19 cents. And this is in dollars, right? That's a cost of a truck. And finally, when will the truck be worth half of the original price? Okay, well, half, what does this mean? Okay, well, half of 24,500 is 12,250. So what we're really looking for is when will the truck be worth $12,250. Bless me. Okay, so that's going to be the cost of our truck. To the t, right? And now we're solving for t. Okay. Again, we looked at doing this type of equation, or solving this type of equation today in class. So again, most of this is kind of a review of what we've already done, but with word problems. And so again, we're solving, and we want to get what's being raised to the power by itself. I'm going to divide by 24,500. This gives us 1/2, which makes sense because we're looking for half of the cost. Now I'm going to do what we did in class today, right? To make my loop make sense, I just switch them. So 0.87 to the t equals 1/2. Then when I loop around, we get log of 0.87 of 1/2 equals t. And I'm just going to type that in my calculator. Again, the log is here. Log of 0.87, log base 0.187 of 1/2. Right? And we get 4.9777, we are going to round to 5 years. All right, looking at example 2. In Colorado, there has been a recent increase in the bear population. Carly started studying the bears in 2014 and found there were 1,573 bears in the national park. The population increases by 2% each year. Write an equation. So our equation is going to be y equals a times. Now I decide if these are increasing or decreasing, right? There's an increase, so it's going to be 1 plus r to the x, or to the t, right? You would like to use different variables. You could put like p for population and t for time, whatever. So we have y equals, a is our initial value, right? So Carly started studying the bears and found there were 1,573 of them. And then times 1 plus, they're increasing by 2% each year. Again, there's a decimal here, we move it twice, that gives us 0.02. Just writing this out nicer, y equals 1,573 times 1.02 dx. Okay. Looking at B, how many bears will there be in 2025? Well, since I started in 2014, this is t equals, right, 2025 minus 2014, which gives us 11, right? So basically what this is saying is 2025 is 11 years after 2014. So I'm going to take my equation, and now I am raising this to the 11th, which equals, is it 1,573 times 1.02 to the 11th. We get 1,955.83 bears. It'd be even more terrifying to have 0.8 of a bear running around. So we're going to say 1,956 bears. When will the population reach 2,500 bears? Now we know the amount, so now we know our y. Solving for x, and this is what's being raised to the base, so we want to get that by itself first. So we're going to divide by 1,573. And that fraction stays exactly how it is, and we're going to leave it. I would rather have fractions than rounding any decimals. It's going to give you a more exact answer. Okay, these cancel out. We're left with 1.02 to the x. And we're going to switch these around to make our loop make sense. Loop on through. Log base 1.02 of 2,500 over 1,573 x. We're just going to type that right in our calculator. So it's log of 1.02. I'm going to type this fraction in. We get 23.39, blah, 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 blah. We'll round down. It's going to be about 23 years. Okay. But I want the actual date. Again, this is telling me 23 years after 2014. So 2014 plus 23 is 2037. And so in 2037, there should be 2,500 bears in the park. All right, let's look at our next page. This is another type of formula. We've looked at our typical, just like rate of growth and decay. The other type of formula we can have is an interest formula. Most times, if you put money in the bank, they'll give you interest, and it's called continuously compounded interest, meaning you're always gaining interest. It doesn't just give you interest like every month, like a credit card isn't continuously compounded. It's just monthly. Where if you have money in the bank, it's more likely to be continuously compounded, or the stock market, or something like that. And the formula for continuously compounded interest is A equals P times E to the RT. Okay. So what do these mean? A is your final amount. P is your initial amount. It stands for principal. Okay. That's why it is a P. That's how much you put in at the beginning. E is the letter E. Okay, we've used it before. It's that natural letter, so E doesn't really stand for anything. R is your rate. And then T is time, usually in years. So, looking at example 3, your parents invested money towards your college tuition when you were born in an account with continuously compounding interest. The growth of the account can be modeled by the function A of t equals 5,000 times e to the 0.085 t. How much money did your parents initially invest? Okay? So this is asking for your initial amount. Okay? So again, that's that P, that's what's in front of the E. It's kind of in the same place as our initial amount is for our other type of function, right? So you initially invested $5,000. What was the interest rate for this? Well, our rate is R, right? This is in a different place, but it's up here. So 0.085. All right, we move that decimal place twice to give us 8.5%. And then how much money will there be when you are 18 years old? That is giving me a time. So A of 18 and then make sure you do times 18, or if you always put things in parentheses, it will know to multiply it for you. So we're just plugging 18 in there. So when I plug this in, it's 5,000 times E. E to the X is here. Again, E is also, if you look in this menu, but we are raising it to a power, so you could just hit this e to the x button. And we have 0.085 parentheses 18. This 18 is up in the exponent with it. Okay, so that t is up in the exponent. We hit enter, and in 18 years we're going to have $23,090 and 90 cents. Good chunk of money for college, right? So for D, how long will it take to have $15,000? Okay, so now I know the amounts. So we want to get to what's being raised to the exponent by itself. E is my base, that's my exponent. Okay, so I'm dividing by 5,000. So that's 3, right? 15,000 divided by 5,000 is 3, equals e to the 0.085 t. Again, I'm going to switch these. And I'm going to do my loop. So the natural log, because it's base e of 3, still solving for t, so I'm going to divide by 0.085. And this is what I'm typing in my calculator, right? The natural log of 3 divided by 0.085. So control natural log of 3. And we get 12.9, or I'm going to say 13 years. So it'll take 13 years before you have $15,000. All right, last problem. Mark just made his first $100. He has decided to invest the money in a savings account that has continuously compounded interest rate of 7%. Okay. So we first want to make an equation. So we have A equals P e to the RT. Okay, so A is one of our variables. It just says how it is. P is our principal. He made $100. E is just the letter E. R is our rate of 7%. Again, moving that decimal, that's 0.07. And then T, right? T is another variable. Okay, so really the only things you're putting in is P and R when you're making these equations. How much money will there be in this account in 5 years? So I know my I know my T, looking for A. And then T is in 5 years. And again, we're just going to type that in. We can do e to the x, and it's 0.07. And parentheses 5, and it'll make sure it multiplies it for us. And in 5 years, we'll have $141, and we'll round it to 91 cents. And then when will he double his money? So if he doubles his money, that really means he's going to have $200, right? So that's going to be our amount. We're solving for t. So same way, e is our base, and we're raising it to that power. So we're going to start by dividing by 100. 200 divided by 100 is 2 equals e to the 0.07t. Switch them. E to the 0.07t equals 2. Loop to switch to logarithm. Again, e is natural log of 2. If I'm solving for t, I have to divide by 0.07. And this is what I'm typing in my calculator. And we can do the division sign first to make sure we're typing everything in perfectly. And we get 9.9, which will round to 10 years. All right, and that is it. I'll see you guys on Wednesday.